Hi, in this video we will present our project, the IoT set platform, able to manage the services required by a specific environment, like your home, your office, or eventually a factory, to improve its living or working conditions, optimizing the energy consumption. Firstly, we will introduce the network architecture used by the devices to communicate with each other. The environment catalog provides both information about endpoints of the devices, the resources and the services in the platform, and the configuration settings for applications and control strategies, exploiting the REST protocol. All services described need to be constantly in contact with the environment catalog, which keeps track of the connected devices through REST web services and eventually edits their status. In this way, all services will be always guaranteed. The Raspberry Pi stands the message broker, which by means of the MQTT communication protocol establishes a connection between who publishes the message on a specific topic and who is interested to listen to it. The Raspberry Pi connector allows to use the board as a device connector, a platform able to connect all the devices. It is mainly needed to two complementary objectives, to sense and to actuate. As a matter of fact, the board is equipped with temperature, humidity and simulated light sensors to provide information about the status of the environment of interest. Thanks to the Bluetooth in the Raspberry Pi, the system can identify the signal generated by a beacon, which corresponds to a user presence in the environment. The information about temperature, humidity and light are retrieved through a REST protocol, while the user presence is collected through MQTT. In order to reach the desired environment conditions, the system manages two smart plugs as actuators. They are directly connected to two devices, an air conditioner and a lamp. It retrieves and changes the connected appliance's status through REST protocol. While it works, sends an MQTT subscriber to receive actuation commands from the control strategy sectors. All these data are drawn by the environment catalog to keep track of the active devices, and at the same time they are used by different actors. The controllers, which compose the control strategy services, and the ThinkSpeak adapter, which uses an MQTT subscription to collect them. The data are then uploaded on ThinkSpeak, an open data platform for the IoT, to store, post-process and visualize data through REST API. Let's now take a look at the controllers. There is a status controller which requests information about user presence as an MQTT subscriber, and through REST protocol to the environment catalog about the time schedule in order to produce an activity status associated to a particular moment of the day, and publish it through MQTT to the other controllers and to the ThinkSpeak adapter, which will use them for the neural network analysis. The neural network controller retrieves from ThinkSpeak every week the status collected from the ThinkSpeak adapter and sends the predicted user presence of the following week. The humidity controller, the light controller, as well as the temperature controller, based on the status, retrieve the thresholds from the environment catalog in order to compute the proper output required by the actuators. They are all MQTT subscribers to retrieve the status and publish them as actuation commands for the actuators. An easy way for the user to keep everything under control is the freeboard dashboard, in which it's possible to visualize with diagrams the data coming from the IoT devices and the user presence prediction of the next week to modify eventually the time schedule of a catalog in order to reduce or increase the activity time. A more user-friendly platform is the Telegram bot, which proposes a cloud-based infrastructure and allows the user to take information about the environment and to change the desired comfort values. It retrieves information from the sensors on IoT devices, exploiting the REST web services provided by the Raspberry Pi. It also retrieves environmental measurements data from ThinkSpeak and displays them in the chat. Let's now see how the system works. This is the working environment where we have tested the whole platform. Here is the environment catalog. We can see that all the devices and services are connected to it through REST protocol. Here is the Raspberry Pi connector, which allows to show the retrieved values of temperature, humidity and simulated light with the REST protocol. The beacon detector, which belongs to the Raspberry Pi connector, displays the user presence by setting a bit. Next, there is the plug wise. In this moment, it receives an actuation command from the temperature controller to switch on the fan. Then all the data are stored in ThinkSpeak. Here is the status controller. As well as the other controllers, when it starts has no information from the outside. Only in a second moment it retrieves the activity status according to the timetable and the user presence. Then it is published to the neural network controller. The temperature controller publishes the actuation commands to the plugwise one. The humidity controller publishes the actuation commands to the plugwise 2. The light controller maintains constant the light in a room by applying an actuation to a lamp according to the detected activity status. Here is the neural network controller, which as we can see is trained by a dataset in order to obtain a good result for the prediction. In the ThinkSpeak PowerShell, it is possible to observe all the information sent from the devices and services provided by the platform. In the Freeboard dashboard, it is possible to watch the values of temperature, humidity and light coming from the Raspberry Pi connector, as well as the energy consumption of each smart plug. Another important feature is the neural network prediction of the following week, in order to manage as well as possible the energy usage in the environment. And lastly, as shown in the brief demonstration, with a Telegram bot the user can be informed of the environment characteristics and change them at will.